Part C, we want to find the x-coordinates of all points of inflection for the graph of f, and give a reason for that. So we'll get inflection points when the second derivative changes signs. We're looking for the second derivative to change signs. That's going to happen when the first derivative changes, whether it's increasing, sorry, it's first derivative, not second derivative there, increasing or decreasing. So let's look at this. They tell us that we get horizontal tangents for f prime at -1, 1, and 3. If f prime is horizontal at these things, that means that the second derivative is 0. That's not enough to guarantee that we have inflection points, but in this case, those will be the inflection points. We can see that from -3 to -1, f prime is decreasing, which means f double prime is negative. From -1 to 1, f prime is increasing, so f double prime is positive. From 1 to 3, f prime is decreasing, so f double prime is negative. And from 3 to 4, f prime is increasing, so f double prime is positive. So that means that f is concave down here, concave up here, concave down here, and concave up here. So the x-coordinates are, so the inflection points will be at x equals -1, 1, and 3. And we have inflection points at -1 and 3, so at x equals -1 and x equals 3, f prime changes from decreasing to increasing. So f double prime changes from negative to positive. At x equals 1, f prime changes from increasing to decreasing. And that means that f double prime will change from positive to negative. So change from concave down to concave up to concave down. And if I were writing this out, I'd put a little of that information down, not just about f prime, but either about f double prime or about the concavity.